So we've already talked about the differences between chemical and physical properties. And to kind of get us into this, what are some of the main differences?
Chemical and physical?
Yeah.
Well, said physical, you could see it. Chemical, had to do it.
Right. And so what we're going to be focusing on are very specific physical properties. We're not going to actually be talking about any chemical properties. And the two that we're going to be talking about is extensive and intensive properties. Now, when we're talking about extensive properties, we're talking about something about your substance that changes based on how much you have. The amount makes a difference. For example, I have 2 beakers of water. And what's the difference between, what do you notice about the 2 of them?
Well, there's very clearly different amounts of water.
Right. And so if we're looking at the fronts, we can actually see that the volume is different. And volume is an example of extensive properties. Some other examples could be the mass of something. How would you change the mass of a block of wood?
Cut it in half.
All right. So if you've got less stuff, you have less mass. The other one that we have is intensive properties, and that's basically the opposite. How much you have doesn't make a difference. The property stays the same. Now, I have, in the same beakers of water, I have 2 thermometers.
Right.
Now, if we take a look, what's yours say?
It says it's at 22.
Yeah. So mine has 22 as well. So we know that the amount is different, okay?
Right.
But temperature stays the same.
Okay, so temperature is intensive.
Right. Couple other examples that we can use. Conductivity, if you have a piece of metal. All right. If I get, check this out. So I have one of these, okay? Now, if I give you another one, does that change the conductivity of that scoop? Is it going to stop conducting electricity, or?
I imagine it would shock me either way.
Probably. Okay. So however much you have, it's still going to be able to conduct electricity.
Right.
Density is another one. Okay. The density of the water isn't going to change. Now, I presume later we'll be able to figure out exactly what density is. Solubility is another one. The fact that you can dissolve.
Yeah, forget about the spout.
The salt so we've got stuff dissolving in both of them. Did the fact that we're dissolving salt change with the amount?
Well, it still dissolves.
Right. Another thing is if something is brittle, if you can break it or not. If I have a big piece of glass or a little piece of glass, is it still brittle? Is it breakable?
Still going to break.
Right. So none of those things make a difference based on your amount. They are inherent within the substance.
All right, so we had extensive properties, amount mattered, changed when I changed the amount.
Mm-hmm.
And intensive properties, it doesn't matter how much I have, the property's going to stay the same.
Right.
Makes sense.
Awesome.
When we're talking about properties, we can also talk about the physical properties of the 3 states of matter, which are solid, liquid, and gas. There's a bunch of other states of matter. We're not going to talk about those right now. When we're talking about the properties, the specific properties we're going to be looking at are the density, the shape, what happens to the shape between containers, the volume, how much space it takes up. That's also going to get us into a discussion about how compressible something is. And then we're going to have some examples. So you have those on hand. When we talk about density, we're going to say that solids have the most density. That means they have the most stuff packed into the same amount of space. And if you take a look at the picture that we have here, we see that we do have the most particles in roughly the same amount of space. And they are nice and orderly. They fit together a certain way. They're in nice little rows. And when solids form together like that, they create a crystalline structure. They make little crystals, like quartz crystals. Diamonds are another really good example of crystals. That's just the regular setup of the particles. And that allows you to pack in as many particles as possible into a space. If you look at the opposite side, gases, there's a whole lot of space in between those particles. All that white in between all those little particles. So that means that the density is going to be the least. And then liquid is in the medium, in the middle, so it's going to be medium. We're talking about shape. We're talking about, what it looks like. Is it a cube? Is it a sphere? Is it pen-shaped? People-shaped? Whatever. Solids have a definite shape. That means it's not going to change. If you take a pencil or a pen and you take it or you put it in your pocket, put it in an envelope, put it in a jar, the shape of the pencil doesn't change. It is definite. Liquids and gases aren't like that. They take the shape of their container so that they are indefinite. Your soda is going to be bottle-shaped in the bottle, and when you pour it into the cup, it's going to be cup-shaped. And the same thing with gases. Volume, the volume with a solid and the volume of a liquid doesn't change if you change its surroundings. Your volume of soda in your bottle is going to be the same as the volume in your cup. The same thing with your solid. The volume of the pencil doesn't change if you put it in a bottle or a cup. So it's definite. Gases, it does change. Gases take the shape and volume of their containers. So if you take 100 milliliters, which is volume, of a gas and you put it in a 200 milliliter bottle, your volume is going to change to 200 milliliters. That also allows it to be compressible. All of that space that we talked about in between the gases, well, you can squeeze those particles together so you can compress it. You can take 100 milliliters of gas and you can put it in a 1 milliliter container because you can squeeze out all that space. Liquids and solids, the space isn't there, so you can't squeeze them together anymore. Some real quick examples: salt, diamond are examples of solids, especially good crystalline solids. Other solids are the computer you're looking at, the desk you're sitting on, things like that. Liquids, water, soda, oil, any type of oil. Mercury is one of the only elements that's a liquid. Gases, anything in the air, oxygen, carbon dioxide, helium for our balloons, neon and the neon lights, those are all gases. So they have the least density, they're compressible, all that other good stuff. We're going to be talking more and more about these different phases of this different states of matter and the different properties in a lot greater detail later.
So when we're talking about the states of matter, one other thing that we can look at is how the particles are arranged and how they move between the solid, liquid, and gas. And earlier we had talked about how in the solid the particles are packed together. And so when they're moving, they're just going to kind of stay in place and shake. They're still moving. They're always moving. They just don't have a whole lot of room to move in. With the liquids, they're moving around. They're kind of flowing around each other. And that's how you can pour out your liquid. That's why they take the shape of your container. And then with your gases, there's a whole lot of space. So they can move around all over the place. And that's why, with all of that space, you can compress your gases. And you can't do that with the other two.